is a talk about multiplayer experiences with React. So let's hope that the internet works. Otherwise, it's going to be a short talk. But we can go lunch early. So we're going to see how to integrate like multiplayer components in our React applications using 2 case studies. And we're going to see 3 different tools. But first, a little bit about me. I'm a graphic designer and a developer. I work at Basement Studio, design agency from Argentina. And one brand that we usually work with is Brazil. And last year, they contacted us because they wanted to do the new site for the Next.js Conf. And of course, they wanted to add a multiplayer experience in the hero to make it a little bit more engaging. So we started iterating on the design and thinking what it could be about. And the basic idea was that people should be using like the building blocks of the framework to like create something together, whether that's like a UI or something. So we started iterating over and over. And we ended up with this design, which is like every block is one feature of the framework, and then every letter is a category. So the objective was to place every feature in the corresponding category, and when a letter was completed, it filled up like the entire letter, and once all of the letters are done, you win the game. And of course, it was multiplayer. So people can work together or against each other. That was really funny. So how can we go about creating a multiplayer app? So imagine if I want to tell the server that I'm moving a block. If I do like post requests every time I move a block, that's going to be slow. I'm going to do a lot of requests. So what we need is a WebSocket. So imagine if a post request is sending a message and then receiving a response. A WebSocket is like having a phone call with the server. So your computer can, at any point, send a message, and the server can, at any point, send a message back to your computer. So that is way faster, and it is ideal for this type of experiences. But handling all of the sending and receiving messages, it's a lot of work. So of course, we choose a library that will abstract everything out of the way. And for that experience, we choose Liveblocks. And within a couple minutes, we got something working with it. And it's really cool because they abstract everything that has to do with the servers, and you just focus on what's happening on your computer. And they do that but by providing the thing that React developers love the most, which are hooks. So there is, imagine we have a state that is multiplayer, like a set state but shared between all of the people in the room. So we can read from that state using storage, and then we can mutate that state using use mutation. And every time anyone on the room mutates the state, it automatically re-renders any computer that is connected to that room. So let's see a quick demo of it working. So I hope it, yeah, great. Okay, so here I have a really simple app. It's a bunch of checkboxes, and each time I click a button, you can see on the other browser it's updating. But one thing we have to really worry about when we are doing multiplayer experiences is performance. And why? Let me enable this tool here, which is React Scan. This is a really tool to debug re-renders on your application. So every time any component gets re-rendered, it's going to be highlighted on the screen. So if I touch here, I can see that that is not good. And the problem is also that I am re-rendering my entire screen. I am re-rendering someone else's entire screen. So if we have 10 people clicking boxes, that's not going to scale really well. So let's go to the code and see what's happening. The other side, all right. So on the boxes component, we are using storage to subscribe to this multiplayer store. and we are grabbing the store, the checkboxes of that store, and we are just returning the entire checkbox. The checkbox has its ID and a checked state. And they weren't just looping over that and using this box component to render it. So pretty simple app. The problem is that since we are subscribing to this entire, the entire store, every time any single checkbox changes, it's going to re-render this entire component, and it's going to render the container and all of the boxes. So one optimization that we can apply is first using memo. So const memo box equal memo, that's not equal. All right, so now if I go and click, and let's refresh. Much better. So we only are re-rendering the box that we are clicking, but it's not that good because we're also re-rendering like the container div. So what is happening here? I mean, we are still subscribing this hook to the entire store, and we are re-rendering this component every time any box change. So what I like to do to prevent that is instead of like just querying the entire store and returning that, I like to subscribe to the IDs only. That those rarely change, except if we add or remove boxes, but that's not happening here. So let's edit this component real quick and remove the check state. So now the box only receives the ID, so that's going to avoid any of these re-rendering whenever we change anything. Now we have to query on each box its state. Let's say const check. Oh, storage. Let's grab the checkbox by ID and then just return if it is checked or not. So this way, whoops, spoiler. This way we are only rendering the thing that is changing. So this example is pretty simple, but if you have a bigger app with a lot of multiplayer components, it's important to take into consideration the performance of it. So after implementing all of that and polishing a lot the visuals, we ended up with this. And one bug that we had is we trying to prevent users from placing one block on top of another. So what we did was kind of a logic where you checked if the space was empty or not. And if it's not, you search around until you find a space. The problem is it has a small delay. So maybe you're placing a block and another person in the other side of the world is also doing the same thing on this same place. So both users think that that space is empty, so they push the block to that place, and that's a valid mutation. So we kind of struggle with that a little bit, and the way we solved it is one of the computers on the entire room is going to be constantly checking if something is like not as it should be. But again, we have a similar problem. How do we select what person is doing all of those checks? I mean, you could also handle the server by yourself and solve that on the server, but in this case, we only control what's happening on the client side of it. So what we did was create a score. Since that person is going to be performing extra calculations all the time, it was logical that the person with the best computer is going to do all of those extra checks. So we calculated a score based on the GPU and the battery level and whether or not you are on the tab. So taking all of that into consideration, it assigns you a device score, and the person with the base device was the host. And if a person is going to perform all of the extra checks. If a person with a better device enters into the room, then that person is going to assign itself as the host. Now we needed to test this, and it was kind of hard being on Discord and 3, 2, 1, drop the block. It was not scalable. So what we ended up doing, in our case, it was really, really useful, was to create some bots that automatically do a lot of updates to kind of stress test the application. And you can see that sometimes the blocks are at the end of the game. Some blocks are misplaced, and the host is saying, hey, this block shouldn't be here, so it just move it back right there. So that was solid enough. The site is still live on the domain webby.nextjs.org. And it says Webby because the site is also nominated for the Webby Awards. So, and the votes closed today. So if you like it, and I encourage you to enter to the link and to vote for the project that you like the most. I hope that the project is the one that says Basement Studio below it. Moving on, what happens if I want to control the server? Well, there is a different tool called PartyKit that we tried. And with PartyKit, you implement your own server class. So you're going to be receiving all of the updates from the clients. And in this case, for example, it's like a chat app. So every time it receives a message, it pushes to the messages array, and it broadcasts. This means that it will send all of the messages array to every person in the room. And also, you can handle, for example, if a new person joins the room, you can send all of the messages so that it will have all of the history chat. From the client's perspective, this could do something like this. They have a hook, so you can connect to the socket easily. And then every time you receive a message from the server, you can, I don't know, update the state or do whatever you want with it. In this case, it's updating the messages array, so it kind of render everything. So we wanted to try this by creating a little racing game. And our first approach was, okay, let's send the position of the car and the rotation to the server constantly, and the server is gonna take that position and send it back to everyone else. And that worked. It worked pretty well, as you can see. But it has an issue when multiple people join. And why is that? If you're sending on every frame an update to the server, you're going to be sending 120 updates per second. And the server is going to do the same to every other user. And as we start adding users and users, that's going to be a problem. So we need to find a way to solve this issue. So after trying a couple of solutions, we found out that the first step is to go and vote for the Webby. That really helps, seriously. The second step is to define a time window. And let's imagine this is the server, and this is like a timeline of all of the events that are happening. And these are all of the users that are going to be sending the server their positions. So instead of each time just resending that position to everyone else, let's just group together all of the updates, and once every couple milliseconds, send all of the updates back to the client. And you can do that again and again and again. It's basically a throttle. So now, let's pray that it works. Right. So we have some people back in Buenos Aires playing the game. I'm also gonna go and join here. So this works pretty well. As you can see, I'm also playing on my phone, and it's that car that is moving there, and it's pretty smooth. Since you're not sending that many updates, then you need to lerp between each position, so it can look like if you stop suddenly, you can see that it is correcting the position because it's really assuming where you are based on the latest position and velocity that it received. So then, oh, here they are. The streaming has lag, so they just realized. Okay. But it works pretty well, and since we are not sending that many updates, the idea is to test how far can we go with users. And since you all have phones and hopefully internet connection, we're going to try it together. But first, another demo, because there's also another type of multiplayer that we can add to our applications. And this one is really interesting because instead of connecting our computer to a server, we can connect our computer to another device. So using PRJS, of course, to help abstract all of this, we can, for example, if I scan this code here, this one is the most challenging to work on the Wi-Fi. But come on. Someone else scanned the QR code? Okay, it's working. All right, some person is using their device to control this, and it works pretty well. So basically, it uses the gyroscope of your device, and it informs that position to your. Thanks, by the way, to this device directly. So it doesn't have that much lag. And then this device is in charge of like updating the position to the server. So it's two types of multiplayer at the same time. All right, I'm gonna reload. To that, we of course used PRJS, and since it didn't have a React implementation, we made one to kind of abstract a little bit more into the React application. So basically, you type the messages that you want to be able to send and receive, and then you create a party using those types, and then you basically have hooks that you can, and the multiplayer instance that you can use to connect to another device using their device ID, and you can send a message and also use this hook to like handling receiving messages. We just published it yesterday, so it's there. So now the idea is that we all go into miami.basement.studio with our phones. Try not to use the Wi-Fi, use your connection if possible. And let's see how many people we can get until the server melts. So it's miami.basement.studio. I'm going to switch the tab now. And let's start. Also gonna go here and, of course, enable the debug mode so we can see other people playing. All right, so 17, 19, 20, 22. So 46, it's working pretty well, but what's happening there? All right, let's ignore that. All right, so we have 70 people still holding up. By the way, this is open source, so it's on the, if you enter to the link, you're gonna see the GitHub icon there. So if you want to like get more in depth into how it's implemented, you can, of course, read the source code. But okay, 86 people. Come on, we still have room for improvement. We have 3 minutes, so I'm just gonna stand up here until it crashes. Does anyone have a question in the meantime?
What did you use to build the track?
Blender. One of our 3D artists saw me struggling with Blender, and he just he just built the track. This was like 3 days ago we started the project, so it was really fun. Oh, by the way, a nice tip is that we also use Bayhub to handling all of the assets. So let me show that in the meantime.
So does that Go server?
It has a server. It's a PRJS server, so they are paying for that. You can also deploy it to your own server as well. One way to use Bayhub that we really like is just use it as a place to throw all of the assets and then querying that. So that is a really nice pipeline to work with the artist. So we just connect that, and they can iterate and see all of the preview in 3D. And we can just focus on the code. It's open source. If you click on the GitHub icon, it's going to take you to the repository. And it's a monorepo. So in the apps, you have the front end, so the entire multiplayer application. And on the server, well, it's the PartyKit server. And then there is a package called game schemas that has the types so that it can be shared between the front end and the back end. So that was really helpful to code this thing. All right, numbers are going down, so thank you very much. We didn't melt the server, so that's great.